there have been a couple of other companies and flagship missions that have gone out to asteroids. Um, in the map of those missions, how do you see what you've learned from them and what lessons you can take and put into Vestry Plus?
Yeah, so I mean, let's go through them. Number one, there's one on its way right now, which is called Psyche mission, and the PI for Psyche is someone named Lindy Elkins Tanton. She's at uh, Berkeley now. Lindy's been an advisor to us for a number of years and is extremely helpful with getting on a call with her and just saying like, "Hey, Lindy, I'm not a geologist. I actually have no idea what the fuck I'm looking at. Can you help me? Like, where do we go for this? How do we think about this? Is this assumption right or wrong? Do you believe this?" And like, Lindy is probably one of these scientists that will go down in history 200 years from now, and people will really be like, "Wow, that was one of the greats." As we looked at it, she's exceptional, and having people like that have built these missions that have gone through all those edge cases, but also have looked at a lot of the data coming out of telescopes to say like, "Oh, we think this is happening with Psyche 16, and we're going to correlate that data shortly." That all feeds directly into how we choose asteroids. People like Dante Loretta, who is the PI for the OSIRIS-REx mission. It's great to have somebody like that on our team that we can look at and just say like, "Hey, we're doing this. Does this trajectory make any fucking sense? Or what's your concern with this? Like, you saw it on a $1 billion program. Was this an issue or not?" Right? I mean, to be clear, both of those people have been exceptional in helping us as we go through. But it also goes down to people like, you know, people that work at Planetary Resources. Chris Lewicki's been extremely helpful. Matt Beasley has been some of the most helpful when it comes to things like imagers and just, sometimes you talk to some of these guys and just say like, "Hey, this is what we're doing." And they're like, "Well, you're an idiot and here's why." And like, they just saved you 2 years of development time or figuring that out for yourself as you go through. And those people are like, just so helpful in paving the way for us. So the missions before us, like, to be clear, we wouldn't be here without them. I think it's even that level of extreme. Like, AstroForge does not exist unless we know how to do these missions. We know how to go out there. We understand asteroids. We're looking at them, planetary defense missions, things like that. Like, all of this has to come before you can really take a shot at this.
What specific sets of data are you looking from, like, say, Psyche, or any of these? I should say, are they trying to refine their confidence in composition on these metallic?
I mean, look, so what do I take from Psyche? Psyche's an EP mission. Psyche actually had a failure on the EP system recently, right? And so, like, we want to understand as much information as we can to, like, why'd that happen? How do we not? How do we make sure it doesn't happen, right? What are we missing on EP? How do we think about spacecraft design? I can go look at ASU. They have a giant ass model of Psyche. Like, go look at it. Those things are actually really helpful to point at it and say, like, "Oh, I kind of understand why they did this or why they did that. Cool. My spacecraft can't be this big. I can't launch it dedicated on a Falcon Heavy. So what am I willing to chop off? What am I not?" And like, the fact that somebody's gone through all those trades and then you can relook at those trades and apply different criteria to them and get a different answers, it's hugely beneficial. You have to do the trade. And like, they've done a lot of that work for us.